Okay, here we go. Um, I just went to a scratch sheet of paper for this one, guys. This is the last one. Oh, all right. Okay, so here we go. This is the problem that we're going to do. Oh, whoops. Shouldn't be 2. Or shouldn't be 0. Should be 2. So I've switched the problem just a little bit. And you may want to do it on a scratch sheet of paper because the one that I designed for you guys was so similar to the previous one. But we want to evaluate this integral by using limited Riemann sums. And so on your test, what you want to do is you want to set it up like this. The first thing I suggest that you do is what we did in box B, which was we defined exactly what the width would be. So delta x was equal to what? Which in this case is? Right? Got that? So now for C, that's the width. Now I want to do the sum of the heights. Well, the sum is just summation, but the heights, where do we evaluate the heights at? And x sub I is equal to a plus I times b minus a over n. So what we end up with is our beginning point, which is 2, plus our width. What's our width? 3 over n times I, so 3i over. So that's what we plug in for x sub I now. That make sense? Here we go. Integral from 2 to 5 of 5 plus 3x minus x squared dx is equal to the limit as n goes to infinity of the summation from I equals 1 to n of what? 5 plus 3 times 2 plus 3i over n minus 2 plus 3i over n quantity squared. All of that, this is a mistake that people make sometimes, we want all of that times 3 over n. That's, yes, it is. No easy way to do this one, just gotta work her through. Limit as n goes to infinity of summation I equals 1 to n 5 plus 6. Ooh, gonna be able to combine like terms there. Huh. That's 9i over n. Uh-oh. Let's square that out and subtract. So 2 squared minus 4. Okay, you want to do 9i squared over n squared? Okay, we'll do that. Minus 9i squared over n squared. And then you got to do 2 times 3i over n and 3i over n times 2. Should be a 12i over n. So if we FOIL that out, you would have 2 times 2 is 4. 3i over n times 3i over n is 9i squared over n squared. But then you have the inside and the outside. So 2 times 3i over n is 6i over n. Added to another 6i over n is 12i over n. And multiply all that by 3 over n. Awesome sauce. All right. limit as n goes to infinity. Just we just say that. It's like no big deal. I'm gonna go to infinity. N and what do we got? Well, we can let's combine like terms first. So sure. So if you took 2 plus 3i over n times 2 plus 3i over n, you have to FOIL that out, right? You get the 4 and the 9i squared over n squared, and then the inside and outside make 12i over n. Okay, so 7 is 3i over n. It's 9i squared over n squared times 3 over n. We're making progress, aren't we? Limit as n goes to infinity of the summation from I equals 1 to n of 21 over n 9i over n squared right? Break it up into 3 summations. You know, in algebra class, you're like, what do we do next? We're like, add 5 to both sides. It's like, what do you do now? What do you do next? Bo's like, break it up into 3 summations. You know, it's like you're a different league. All right. I'm just saying, it's a sign that you're maturing in your mathematics. Mathematics comes from a Greek word, monthano. Monthano means I understand. So the word mathematics comes from the word to understand. Very different from the word that we get arithmetic from. Arithmetic, well, arithmeto, something like that, which means that you calculate basic numerical calculation. Very different from mathematics. So adding and subtracting is not math, it's arithmetic. This is mathematics. This is calculus, calculating the infinitesimal. Okay, what to do? All right. There we go. Limit as n goes to infinity of 1 over n summation I equals 1 to n of 21 9 over n squared summation I equals 1. Yep, you could practice making your summations of I. Got ahead of myself there. 27 over n cubed summation notation n of I squared. Beautiful. Now what? Okay, we're going to slow down. Matthew wants us to slow, get caught up, so we can put forth the big idea. What's the big idea? Yep, time to substitute your sums. All right. So, for example, if we add up the number 21 n times, what does it add up to? 21 n. And if we add up I, first I integers, what does that add up to? And how about I squared? There you go, Scott. Wish Marcus had right answers. I'm just taking a shot at you because you took one at Scott. Okay. Okay, he was applauding. All right, Scott, he was applauding you. All right, I'm sorry. All right, so the n and the 1 over n go away, right? So we have the limit as n goes to infinity of 21 minus, what can I do here? Get rid of one of the n's. And I get 9n plus 9 over 2n minus, get rid of one of the n's, and 27 over 6 will be 9 over 2. Let's see, 2n times n times 9, 18n squared. 2n and 1n make 3n times 9 is 27n. 1 times 1 is 1 times 9 is 9 over 2n squared. Awesome! Let the limit go to infinity. Well, not yet. First, we're going to do just a little bit of algebra. 21, what do we factor out of the top? N times 9 plus 9 over n over 2n. Factor out of the top of the last one. Oh, yeah. 18 over 2. Yeah, that's right. Could have reduced that, I guess. Okay, so the n's cancel. So I get 21. N's cancel. 9 over n goes to 0. 9 over 2. N squareds cancel. 18 over 2. So that means I get, let's see, 42 over 2 minus 27 over 2 equals 15 over 2. 7.5. Whoa. Did I make a mistake, Katie? Yeah, 9 over 2 minus 18 over 2 is 27 over 2. There you go. Let's see. This is the moment of truth, people. What's our function? 5? And we'll zoom 6. So we're going to look from, what, 2 to 5? Well, from 2 to 3, it looks like it's, from 2 to 4, it looks like it's positive area. And from 4 to 5, it's negative, isn't it? So some positive, some negative. And we'll calculate. Number 7, we go from 2, 5. Booyah! Yes! Come on! High five! No, so what it would do is it would count. Yes, I see what you're saying now. So this would cancel off some of that. That's what happens. It doesn't take this is positive, and combine them together. Yep, it says this is a positive, this is negative, and you get a sum total. So, all right. So I got a worksheet for you. You're gonna have all day tomorrow to work on it.